Hi, welcome back. This time we will start by doing the last problem of the ICT, number 6T. Okay, so the problem is asking you to find the equation that best describes what is being said here. So, how to do this? There is a shortcut, and that shortcut can be done. It not all of the times works, but in this case works. And this shortcut is just trying to see when any of these equations gives the correct value for y equals to 1. So which of these equations is providing you with the right answer that you would expect? So in this case, because what it says here is that the publisher will charge you $15 for the first copy of a book, then if you consider this, you would not expect that the publisher will be charging you $12 for an additional copy because you are not asking for that. That means that you would expect that the right equation should provide you with this answer, $15 whenever y equals 1. So let's see which of these gives that value. So the first one gives 15, the next one actually gives 27, the next one gives 12, the next one gives 18, and the last one gives again 27. So because all of them, except for the first one, are not working, that means that just by having this observation, we have been able to see that the solution here is F. So this is a shortcut, but as you can see, for example, two of the numbers were 27. It could also have happened that we could have gotten 15 for both, for two of these equations. That's why I'm saying that not all of the time works. In this case, it worked. But whenever it provide the answer is being repeated, then you have to able to have a method to which you can resort to find like the general solution. Okay, so let's erase this for a moment. How to solve this? A good way of doing this whenever you feel stuck is to make a quick table of different scenarios. So we can start by considering what do you expect when y equals 1? Because y equals 1 implies that you're only getting the first copy of a book, and it doesn't require additional copies, you would get a 15 here. For y equals to 2, you still get the 15 because it's the first copy, but then you get a 12 because you are, for each additional copy, you're getting $12 more. What about y equals 3? Again, 15, but this time, because you are asking for 2 copies, you get this number. So it would be very tempting to immediately make these numbers, let's say 27 and 39. But whenever you do this here, you lose track of the pattern that is being created here. So let's come back to y equals 4 again, because we now have 3 copies. We have this number. And we could actually continue as much as we want, as much as we need in order to see the pattern. And probably you are already seeing the pattern here. For example, this 12, you could actually put 1 here. So 1, 1, 2, 3, 4. And actually here, you could also have just written this. And how are these numbers being related to y and this number related to y? Is there any way where these equations can be written in terms of y? And probably you already noticed. So 15 is always there. It doesn't matter the value for y, it's always there. So you can just write it. But 12 and the amount of 12 strongly depends on y. And this value, 4, 3, 2, are actually always y minus 1. Can you see this? That's why here we should write this equation in this way. Because this equation can actually be further reduced, let's write it like this. we multiply everything there, and we see that this minus 12 can be added to 50. So we end up writing this in this way. And you can come back and see again that F is the answer. Okay, so let's try thinking something different. Okay, let's do something different. Because the previous exercise was taking these numbers and trying to find a pattern for them. We can think that most of these kind of exercises will be solved in the same way. We can just have a sequence. Let's assume, for example, and then you can ask yourself, what equation describes each of these numbers? And you can just start by deciding, is this value when n equals 1 or when n equals 0? Because this defines the origin of your equation. So let's keep n equals 0, and then this one would be for n equals 1, and this one for n equals 2. So what we can see is the difference between these two numbers is 2. Between these two numbers is 2. So we are always incrementing a 2. Okay, so what we can see is for n equals 0, we have 2. For n equals 1, we have 4. For n equals 2, we have 6. Now we can write these numbers in this way. And you can already start seeing how is this number that is being incremented related to n. It's basically n plus 1. So by doing this brief analysis, we see that the rule here is given in this way. For n equals 0, we get 2. For n equals 1, we get 4. So, and we can also think in our types of sequences, but this is the way to find how are they being related. To always assign them an n, like the first step, and you only increment this step in this way. And then you try to also see how big is the difference between any of these two elements, if it's constant or if this value is also changing. I hope that with this brief analysis, I have provided you with a tool that is called the inductive method. You can read more about it, and this will definitely always help you to solve this kind of problems. Thanks for watching.